Hey, welcome to
FunMath 161.
FunMath number 161. Today we're moving on to section 9.2 of Art of Problem Solving's Algebra book. And we're running a little low on time because we had to finish up section 9.1. So I thought I'd do one of the 9.2 examples as a fun little problem this morning and see how you thought about it. So we have, here's the question, which is larger? The square root of 3 times the square root of 5 times the square root of 7, all these things under all the square roots. Or the square root of 5 times the square root of 7 times the square root of 3. Whoa. How do you think you want to try to approach a problem like this?
Well, we don't know how to calculate square roots of square roots.
Right, we don't know how to calculate square roots of square roots. So let's look at a simpler problem. Let's ask the question, which is larger, the square root of 3 or the square root of 5? Let's go to a simpler.
7.
What's that?
Other than 7.
Oh yeah, but this is a new problem. This one's too hard. We're going to make a simpler problem first. Which is larger, the square root of 3 or the square root of 5? What do you think?
The square root of 5 is probably larger.
Okay, why do you think that?
Because it takes more to square a number to make 5 than to square a number and make 3.
Okay, very good. All right, so we have one thing we can do, because these are both positive. Remember, inequalities, you can do the same thing to both sides.
Yeah.
Okay. If we know that 3 is less than 5, so now if we want to do the same thing to both sides, because they're both positive,
You take the square roots.
okay, so we can take the square roots. We can raise to powers. That's one of the things we were talking about in section 1. Now, it gets tricky if we flip over, right, if we have negative powers. Luckily, what power is the square root?
It's 1/2.
It's 1/2. So I can do this to the 1/2, and I can do this to the 1/2. Now, I can also do the reverse, by the way. I can square both sides, and that will help me get rid of the 1/2. So if I'm trying to understand this, since 3, if we don't know, 3 to the 1/2 and 5 to the 1/2, I can square both sides, and I do know that 3 is less than 5. So I stay in the same place, okay? With the eraser. Luckily, this marker is the same color as my shirt, so that's okay. Now, so does that give you an idea of what we might want to do here?
We can work inside out. Like start here and work our way out.
All right, how are we going to start here? What would you want to do?
Well, we could figure out which is larger, 7 times the square root of 3 or 5 times the square root of 7.
Okay, but inside these square roots it gets complicated.
The square roots of square roots of square roots.
Yeah, let's work from the outside. We don't know if this should be greater than or less than or greater than. But let's square both sides. What do I get when I square this expression?
It's 3 times the square root of 5 times the square root
3
of 7.
times the square root of 5 times the square root of 7. 5 times the square root of 7 times the square root of 3. Okay, so now it's getting a little bit easier. What do you think I should do next?
Square it again.
Square it again. What do I get when I square this expression?
You get 9 times 5 times the square root of 7.
Okay, I'm going to write that as 3 squared times 5 times the square root of 7. What do I get when I square this side?
5 squared times 7 times the square root of 3.
Okay.
Square it again.
Square it again. What do I get when I square this side?
You get 3 to the 4th
3 to the 4th
times 5 squared
5 squared
times 7.
times 7.
And 5 to the 4th times 7 squared times 3.
Okay, now I can finally actually do a comparison. But there's one more thing I can do to simplify when I'm trying to figure out what greater than or less than sign. How can I make this even easier now?
Well, multiplying out wouldn't make it easier.
Oh no, multiplying out would be
Hard.
But there's one easy thing I can do.
Well, you can check it right here and see which one's larger.
Well, right, but I would have to multiply out to do that.
Yeah.
So how can I simplify one more step?
There's no more square roots left.
There's no more square roots left, but both sides have some very similar terms.
Well, we could like divide by. We could take a power of 2 off. No.
I don't have any powers of 2.
Well, each side has something raised to the 4th power and something raised to the 2nd power.
That's true.
And something raised to the 1.
Okay. So how can we simplify?
Can you cancel any powers?
Good question. Can you?
Well, there's a 5 to the 4th and a 5 squared.
Aha! So how can we make it simpler?
We could divide it by 5 squared.
Okay, what's going to happen to the 5 squared on this side when I divide everything by 5 squared?
That 5 squared is going to go away.
And become a
1.
it becomes a 1. And this side is 5 to the 4th divided by 5 squared
Is 5 squared.
Okay, good. What else can I divide by?
You can divide by 3.
Okay, what do I get on this side when I divide by
1.
3? 1.
And 3 cubed.
3 cubed.
And you can also divide by 7, so you get 7 here and 1 there.
Okay, so now I've got 5 squared times 7 and 3 cubed. Which one is larger? Okay, why is 5 squared times 7 larger than 3 cubed?
Well, because 5 squared is already larger than... No, wait. 5 squared is almost as large as 3 cubed.
Right,
And then you're multiplying it by something way larger.
way larger. Or the other thing you could say is this is 3 times 3 times 3. This is 5 times 5 times 7. So I've got 3 integers multiplied together. These 3 are already larger than each one of these. So that means, of course, whoops. That means this is greater, so this is greater, so this is greater, so this is greater, so this is greater.
Woo!
Pretty cool.
Yeah.
Complicated, but luckily all we did was square, 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 divide, and we got an answer. And since everything was positive, we were squaring, that's positive powers. Squaring positive powers, squaring positive powers,
And no
dividing by
yucky
positive
negative.
numbers.
No yucky negatives.
No yucky negatives. Okay, good job, sweetie. I think we ran a little long on this one, but hopefully it's still useful.